And good evening, everybody, or whatever time of the day it is where you are. And welcome to Serverless Days Amsterdam, our June meetup, and our last meetup before we take a summer break to enjoy the fantastic weather that we always get here in the Netherlands. It's always sunny in Amsterdam. I'm joined with me tonight by Andrea. Good evening. How are you?
Hey, good evening, or as you said, whatever the time is it where you are joining from. I'm very good. I'm really pleased by the weather, as you mentioning this week. I think we rock it here in the Netherlands. It's summer already.
It's beautiful today. I mean, I actually had a meeting with actual people today, socially distanced, and we thought we'll do it on the beach because it's a Wednesday. The beach isn't busy on a Wednesday during the school term. It was packed. It was horrible. It was 20 minutes to find a parking space. Thankfully, the beach wasn't quite so full, so we could still stay nicely distanced. But I really wasn't expecting 20 minutes to try and find a parking space with that many people trying to get into Zandvoort. But it was nice to get out in the sun for a change. It's nice to have the sun. So we have two amazing speakers lined up for you tonight. But before we introduce the first of our speakers, we're just going to do our introduction to our meetup itself. So, as I said, welcome to Serverless Days Amsterdam. And yeah, we are still on an online meetup because we're still doing most things virtually. Who knows? It might change later on in the year. The vaccines are rolling out. We'll see what happens. As a reminder, not for the next 2 months because we're taking our summer break, but we do our meetups on the first Wednesday of the month. So come and join us for some fantastic information and insights into how we can move our code into the serverless world. We have a few house rules that we want to go over before we start. First of all, we have a Discord channel, and we invite you to come and chat to us there. If you've got questions for the speakers, you can put those there and join in the conversation with us. And of course, we also have our code of conduct, which even though this is an online meetup, our code of conduct is still in force. So please take a look and make sure that you understand what we want to do to make sure that we can keep this a safe space for everybody. Last thing that I want to say before we get into our actual speakers is we are always looking for new speakers. If you want to be a speaker, if you want to help us organize, trust me, that's also always appreciated. Then please get in touch with us. If you're a first-time speaker, we would love to help you plan out your talk and give you some tips so that you can give the best presentation that you can give. And there's always room in the world for more people to talk about serverless. So if you want to get in contact with us, you can contact us amsterdam@serverlessdays.io, or you can come to our Twitter account, ServerlessDAMS, or you can contact us in Discord too. So with that out of the way, Andrea, would you like to introduce our first guest?
That would be my honor. I actually know Luc from Sentia. We work at the same company, and I had the honor to be one of its students for AWS certification training that he held inside the company. So I'm really glad that he is going to talk to us today and will share from his experience. So I will not say any more. I will let Luc say more about him. So hi, Luc.
Hi, Andrea, and thanks, Stacey, for the introduction. Let me share my screen.
Okay, so we give you a stream. Right. I'm going to step out and take it away.
All right. Well, thanks both. As Andrea said, my name is Luc van Donkersgoed, and it's my pleasure today to talk to you about reaching peak event-driven architectures with DynamoDB Streams. So let's dive right in and start by looking at what DynamoDB Streams are. Well, technically, it's really simple. You have a DynamoDB table, and you can do a number of operations on them, which are to create an item, to read through query or scan operations, to update items, or to delete items. And whenever you do a create, update, or delete, and you have configured DynamoDB streams, they will stream either to a Kinesis data stream, stream to a Lambda function, or both. And you can also read from the stream with a custom application, but we'll leave that out of scope for today. And that really is all a DynamoDB stream is. So let's discuss on what all the things are that you can do with DynamoDB streams. So first, if we're generalizing data and reading data, there are two types of interactions you can do when reading data. First is you query the data. For example, you do a get my orders or a get a list of all users. And this is where you use state. So the DynamoDB table or any database is in a certain state, and you read the data straight from it. The other interaction is data processing. So for analytical purposes, or to create invoices, or to send out emails based on the data in the database. And this second type of interaction used to be powered by state as well. So for example, every night a query might fetch all orders from the database and then perform analytics on them or send out invoices or reports. But the modern event-driven alternative is to send out a signal, so that's an event, whenever a change occurs, and then process this event in near real time. So processing these mutations as they occur or soon after has big benefits over processing state. Results are available more quickly, individual processes are more lightweight, and you don't need enormous instances, for example, EC2 instances or EMR clusters to process giant amounts of data. Processing mutations as they occur, based on events triggered by those mutations, are the core concept behind event-driven architectures. So to understand event-driven architectures, we'll first take a look at a non-event-driven architecture. So this is a really simple example where a user places an order through an API gateway that is backed by a Lambda function. And that Lambda function will first see if the user has valid payment info, then it will see if the item is in stock, and then it will place the order in DynamoDB. Next, it triggers an external system to actually process the order, and then it sends out an email through SES. But this has a number of issues because this Lambda that has all these responsibilities will have a really high latency. So the user puts a request, the Lambda needs to perform all these operations, and only when all of them have completed will it return a response to the user. There's also a problem with fault tolerance, because if any of these processes fail, then the entire Lambda might crash and the user will never get a response. And there's also not really a way to retry the order except for the user placing the order again. And of course, that is very bad user experience. And the third issue here is variability, because this external API might respond really quickly sometimes, but sometimes it might also be slow and only respond in a second or two. Or there might be network congestion making this API really slow. And that means that the user who's placing this order is really experiencing all of those effects. And of course, that is also not a good user experience. So now let's look at a number of event-driven architectures to solve these problems. And we'll start with SQS, where the user again places the order, it's backed by a Lambda function. The Lambda function still checks your payment info, and it still checks if the order or the item is in stock, because those are essential components of the process. And when those are successful, it will place the order in DynamoDB, but instead of actually sending the process on to the external web API, it will put a message on a queue. And that will trigger another Lambda function, which will perform the actual placement of the order. So that Lambda function will fetch the data from DynamoDB, call the external API, and then send a message over SES. Now, this process can fail, And when it fails, the message is simply put back on the SQS queue, and then it can retry at a later time. Also, this Lambda function does not need to wait for this Lambda function to complete at all, so it can respond much quicker. So all the issues that we had in the earlier design are solved by actually this really simple event-driven design. Now, if your function or your order, in this case, the transaction, needs to trigger a number of events, for example, it might trigger one Lambda function, another Lambda function, and still put the message on the SQS queue, the solution is to use SNS, Simple Notification Service, as a fan-out mechanism. And this works really great if you have control over the entire architecture. So you're building this Lambda function and you're responsible for it, and this one as well, and the SQS queue as well. But if you're sending your event to other teams to process, or you're not entirely sure how many downstream processes there are or will be in the future, there is a third solution, and that is Amazon Event Bridge, where still the order is placed on or sent to API gateway, Lambda processes it, does a thing with DynamoDB, and then puts a message on Event Bridge. And now this Lambda does not know which external system will read that message on the event bus. And it might be one Lambda function, two Lambda functions, or 100 Lambda functions spread out over multiple AWS accounts, and they don't need to be Lambda functions either. There are many mechanisms to hook into Event Bridge. So this is a great solution for distributed teams using many accounts. Now, all of these services, Event Bridge, SNS, SQS, are called the integration layer in a serverless environment. And they really are the integration layer between business logic components. So they link different Lambda functions together, or step functions, and really take care of the decoupling of the architecture. Now let's take a bit of a deeper look at this Lambda function. So we discussed how it interacts with DynamoDB and then puts a message on Event Bridge, but it still has multiple responsibilities. So it interacts with DynamoDB, then does the thing with Event Bridge. But that means if you want to change Event Bridge, change this integration, you now need to update the place order Lambda function. And that is actually outside of its scope of responsibilities, because this Lambda should just be thinking about placing an order and not the further integration in the system. And also, this Lambda function is a bit slower than that it could be, because it's doing a few more things than it actually needs to do. So let's take a quick look at the AWS Lambda design principles. And there are more than these four, but I just took 4 important ones, or 4 relevant ones. And the first one is to use services instead of custom code. So if there is an AWS service available to do what you need to do, you should use it and not write your own. And a simple example is if you need a queue, you use SQS, and you don't go out writing your own queuing mechanism, because, well, that's a lot of work. And it's unlikely that you can do it as well or as well scaling as using an existing service in AWS. Of course, you need to implement statelessness in your functions, otherwise they can't scale and they can't work in a distributed manner. And then there's that you should prefer many shorter functions over fewer larger ones. So your functions really should have the least amount of responsibilities and really clearly defined responsibilities. And if you need more responsibilities, you have to add another function, which you can then, through an event-driven mechanism, trigger. And then the fourth one is to build for on-demand data instead of batches. And well, that's generally the entire thing we're discussing today. So today I want to focus on items 1 and 3, to use services instead of custom code, and to prefer many shorter functions over fewer larger ones. And we'll do that through DynamoDB Streams. And DynamoDB Streams is really another component in the integration layer. So as we discussed earlier, we have the DynamoDB table, and whenever you have a mutation, so that's a create, update, or delete, it will send an event to either Kinesis data streams or to a Lambda function. And this function can be, the stream can be configured in 4 ways. You can do keys only, new image, old image, or new and old images. And we'll get to the details of this configuration in 2 slides. But you should also remember that when you configure DynamoDB Streams, you cannot filter at the source. So whatever mutation happens in your DynamoDB table, it might be an update, might be a create on any kind of object. So you might have users, you might have books, you might have authors, you might have libraries. Any mutation on any of those objects will be put on the stream. So that's a thing to remember, and we'll get back to that later in the presentation. So yeah, the 4 types of configuration we discussed. If you have your stream configured for keys only, and you perform an insert on your table, this is what the event will look like on your Lambda function. So this is the way it looks like when it's received by your Lambda function. It's configured with keys only. It's an insert event. And you can see the keys it has been configured for is a partition key called demo item and a source key called item 1. Now, if you do a modification, you get to see that the event name is modify. You can see which keys the item contains that was modified, but you can't see the actual modification. You only see which item was modified. And the same when you remove it. You only get to see which what the keys are for the item that has been removed, but you don't get to see the actual data that was removed. Now, if you configure your DynamoDB stream for new image and you do an insert, you actually get to see the data that was written. So now it has the partition key, the source key, but it also has creation date and any other fields that might be added to this value, to this item. And when you do a modify, the event name is modify, and you get to see the new image. So this is the data, the way it looks like after the modification. But you can't see actually what was modified. So this is the complete new image. And maybe only one of these values got edited, maybe all 4 of them, but you can't really know because you can't see the item before the change. And when you remove it, there's no new image at all, because of course there is no new image. You only removed the old image. Now then you have the old image configuration, in which when you do an insert, there is no old image because this is a new item. When you do a modify, you can see the values before the modification, but not what they look like after. And when you do a remove, you can see the old image, so you can see what image was removed before it was deleted. And then the 4th configuration is new and old image, and that brings it all together, where you do a new insert, a new item, you get to see what the new image looks like. When you do a modify, you get to see the old image and the new image, so you can actually see which fields were modified and which weren't. And when you do a remove, you get to see the old image that you just removed. Now, of course, new and old images is the most versatile mode because it works for pretty much any use case. And personally, I try to use new and old images all the time. The only downside is that if you have a table with really large items, then your events will become really large as well, and there's a lot of data to process. But in most use cases, new and old images is the safest approach for your DynamoDB stream. So now that we understand how DynamoDB Streams works, and actually it's really simple, it's just events and a single configuration item, what kind of keys and data you want to receive. Let's take a look at what we can actually achieve with DynamoDB Streams. And first, we'll take a look at the old diagram. So this one is still using SQS. Just as a quick refresher, we do a put item. This creates an event. Well, in this image, there's no DynamoDB stream yet. And in our old design, the Lambda function put a message on SQS for further processing. Now, if we configure DynamoDB Streams, that event is still exactly the same, but now that generates a new event on DynamoDB Streams, which is picked up by this Lambda function, and it contains the new image that we just saw a few slides back. Now, in this design, we already removed the SQS part. So that's one component less to worry about, one component less to monitor. Also, the responsibilities for this Lambda function are now reduced to the bare minimum it needs, because it only receives the place order, does exactly what it needs to do to validate that order, and then puts the item in DynamoDB in the DynamoDB table, and then it's done. Any further processing, this Lambda function doesn't care about. But as I said a few slides back, this function will now receive every update in the table. So if this DynamoDB table contains multiple types of objects, so it might have the books and libraries and users and maybe orders, any mutation on that stream will end up in this Lambda, even though this Lambda does not need to process all of them. They only want to process new orders. So now this Lambda function gets, in fact, too much responsibility. We reduced the responsibilities from this Lambda function, but this one will get a lot more, because now this Lambda function also needs to process, I don't know, a create user or a add book to library or any other kind of mutation. So how could we solve this? Well, one thing you could do is add a list of functions on your DynamoDB stream, and each of them receives every single update. So that would look like this, and then drop any event that these Lambda functions receive that they don't want to process. But this is not really an efficient solution, because, well, even though you drop the message really early, you still have some overhead. The Lambda function still needs to be called, and it's simply not really the right approach. So what we can do instead is to, well, have the same design again. We have the place order. The Lambda function puts the order in DynamoDB. But now, instead of handling that order directly with a Lambda function, we send the stream to another Lambda function, which does nothing else but converting any item on the stream into a message that they put on the event bridge message bus. And then that generates a new stream, another stream of events. And that stream can actually be filtered. So this Lambda function can say, hey, I'm only interested in create user events. And then whenever a create user event occurs, this Lambda function is triggered. And this Lambda function says, hey, I'm only interested in place order events. And whenever a place order event occurs, this Lambda function is triggered. And then there's another Lambda function that also triggers on create user. And now we have the kind of architecture where every Lambda function has the absolute minimum of responsibilities. This one only handles the place order call. This one only converts DynamoDB streams to event bridge. And these functions only do the exact thing that they need to do. And this is a really nice design. So now let's look at a bit more of an advanced topic, and it involves DynamoDB single table designs. So a quick recap of what DynamoDB single table designs are. As you all know, DynamoDB has no join statement. So in old relational databases, you would design your database with multiple tables. You would have a books table and an author table. And if you would want to get all the books, including their authors and maybe the biographies of these authors, you would do a select all from book, and then do a left join on author ID from the author table. And that would include all the author information on the books. And this is a really nice way of working. It's really easy to understand, and it's really flexible. And it will work really well when your database is very small. But if your database grows into millions of books and tens of thousands of authors, then it might not perform so well anymore. And then you need to do database tuning and query optimization and all those difficult things, and it will cost you a lot of time. Now, what the designers of DynamoDB said is, we don't want any functionality that will break as the table grows. So your DynamoDB table should perform just as well with 100 items as it should with 1 million or even 1 billion items. And a join does not fit that requirement. So we need alternative solutions to store our data to still be able to quickly request, for example, the book, all the books and all their authors. And to do that, we have to define the access patterns that we will use on our data before we start modeling our data, before we start writing our data to the table. So for our library inventory system, we identified there are two access patterns. One is we want to get all the books with their authors and their bios. And the other one is we want to get all the authors born in a specific year. These are the access patterns. And now we start to design the data in the database. So this is what that might look like. We have a partition key and we have a sort key. The partition key contains books and it contains authors. And the sort key contains the type of the object. So for the first two rows, that's book. And for the second two rows, it's author. And then we have the global secondary index, and we have a sort key for it. And we have some additional data here that we can filter on. And now, if we want to get all the books with the authors and their bios, we perform a query where we say the SK should match book, and that's it. So now we get all the books, and the author is included in this field, and the author bio is included in that field. So one query, and we have all the answers. If we would want to get all the authors born in a specific year, we would query where the SK matches author, and the GSI SK begins with 1926. And now we get all the authors born in 1926, including their bios. But you will see that this field now contains duplicate data, because the author bio is actually in the author row or the author item, but the author bio is also included in the book. So this is duplicated data, and this is something you would not do in a relational database, but it's pretty common to do in a DynamoDB table. So the reason we duplicated this data is that if we would not have duplicated this data, and we would query the book, and we would want to get all their authors, we would first query the book, and then for every single book, we would have to query the author as well to get their bio. So if you would have 10,000 authors, then that means you have to do an additional 10,000 queries instead of those single query that we just saw. And that's why you use data duplication. Now, to manage this data includes or introduces a few extra challenges. So, for example, if we want to update the author bio, we can call a Lambda function, and the simple approach would be to do an update item where the partition key matches the author that we want to update, and then include the updated bio. But if you would just do this, and we would look at our author bio attribute in our table, we would see that the updated bio is here for the author, but here for the book written by that author, we would still have the old author bio. Now, the simple approach to fix this would be to update this Lambda function and say, okay, first we update the author, then we query all the books where the author begins with Harper Lee. So all the books written by this author, and then for every one of those books, we update the bio as well. But now we would be back where we began at the beginning of this presentation, and this Lambda function would again have too many responsibilities, because now this Lambda function should be updating the author, but it's also updating all the books, and it's also querying all the books. So this Lambda function is becoming slow again, and it's becoming more difficult to maintain. So a better solution would involve the design that we saw earlier, including EventBridge, where we would reduce the responsibilities for this Lambda function to only update the book. That would trigger an event on DynamoDB Streams. And this Lambda function converts that into an event on EventBridge. And on EventBridge, there will be a message that the author was updated. And then there's a Lambda that triggers on the fact that an author was updated, and it post-processes this fact. And this Lambda function will fetch all the books and then update all the biographies for every one of those books. And now we're back in a situation where every Lambda has its own responsibilities and clearly, which are clearly defined and short to execute and easy to maintain. So you could say that in this design, the book has a reference to the author. So whenever you update the author and update the bio, you want to update the book as well. Now, if we add an additional field, for example, in our design, we're adding a classics top 10, and that has a reference to a book. So the classics top 10 has the author bio, but also the excerpt from the book. We can see additional benefits to the design that we just discussed. So because this top 10 is referring to that book, whenever we update the book, so here we have the update item, we update the book, we're updating the excerpt, that again generates an event on EventBridge. We have a post-process update book. Now this function can fetch all the books in the classics top 10. And if one of the books matches the book that we just updated, we can update the excerpt there as well. And now this is where it really becomes, well, a bit complicated, but really cool and really event-driven. Now let's say we update the author. So again, we update the author, that generates an event. And that is picked up by this post-process update author. Now, we said the book has a reference to the author. So what this Lambda function does is update the books because, well, the author bio needs to be updated for all of them. Now, that is a mutation in itself because those items, those books, are now getting updated, and that will create a new event, which is picked up by Lambda and put on EventBridge. And that will be the update book event. Now, the update book event can be picked up by this Lambda, which does post-process update books, and that can then update the top 10. So now the classics top 10 is being updated by this book. So in this design, every function has a clearly bounded scope, right? This Lambda only processes the update author. This Lambda only converts DynamoDB Streams to EventBridge messages. This one only updates the books after the author has been updated, and this one only updates the classics top 10 when any books has been updated. So this is a clear and easy to maintain architecture. But also extending this architecture is relatively easy. So if we would include a new field and say, well, we also have a best sold top 10, and there's another book here, The Great Gatsby, well, this one also has references to those books, and these also has fields that need to be updated when the books get updated. But the only thing that we would need to change in this architecture to support that is this update book function, because whenever the book is updated, that's when you update the classics top 10, but now also update the best-selling top 10. Now, DynamoDB Streams are not always the best solution, although they are very powerful and very versatile. But they work best in an environment where you have a low amount of writes, or relatively low amount of writes, and a high amount of reads, like the database inventory or the library inventory system that we saw on the previous slides. If you have an environment that has a high amount of writes and a relative few amounts of situation where the items need post-processing, then setting up DynamoDB Streams would be really expensive. Because you get all of these events, they all need to be parsed by a Lambda function, while the Lambda function probably isn't doing that much. So in those cases, you're actually better off with the old design, where the Lambda function that writes to DynamoDB also does the post-processor. So that leads us to the conclusion. So we've discussed how the design principles for Lambda state that every function should have the least amount of responsibilities possible, and that we should use services instead of code wherever possible too. So with DynamoDB Streams, we can turn any mutation on the DynamoDB table into an event, which can then be further processed downstream by other systems. And this allows us to have very small functions with very limited responsibilities and very short execution times. And this in turn leads to more extensible solutions, higher scalability, and better fault tolerance. So when used right, DynamoDB Streams can turn your entire architecture into an event-driven powerhouse. And that's it for today. Thank you for attending my talk, and thank you for having me, Serverless Days. And with that, I'll hand it back to Stacy.
Hey. Thanks for your talk, Luc. That was really interesting. Stacy, I think you have some technicalities.
Yeah, that was such an interesting talk. Sorry, I was speaking there and I was on mute because, you know, it's 2021 and this is what we do now. But and I've been looking at serverless, or we've been looking at serverless, I should say, in the office, not serverless, but event-driven in the office, some things that we've got coming up. And this was a fantastic start for me to get into. I have a question. I guess it's kind of the obvious question, but outside of the read-write ratio that you were saying at the end there for whether it's worth doing it, are there any other real pitfalls that you kind of need to think about before you go down this route? What are the considerations that that you would say outside of the read-write?
Well, yeah, there's always cost, of course, because, well, every mutation triggers an event. And that triggers a Lambda function. Well, if that runs into the millions of events, then, well, your bill might explode. So that's something to be mindful about, and probably set some billing alerts and every advice there. Also, if you're sending data to EventBridge, as I said or as I demoed in the slides, the amount of data that DynamoDB is sending might be more than your EventBridge can handle, either in amounts of transactions or amount of events, as in payload. So you might want to consider that and set it up as keys only, and then maybe store the payload in an S3 bucket. So okay. Those are a few things to mind.
Awesome, thank you. And so, do you have any questions, Andrea?
Yeah, I think we have a few questions in the Discord channel. So somebody is wondering how to create a more effective update strategy when using DynamoDB.
A more effective update strategy.
Yeah.
I'm not entirely sure what they mean. I'm sorry.
Yeah, maybe we don't have enough details. Maybe you can pick it up after the presentation in the channel. And also another question, that this won't this create a kind of infinite loop of updating?
Well, no, unless you have, well, it's a risk if you have a function that updates the same event, same items that it receives. So maybe that also answers one of Stacy's questions, like something to be mindful of. If you have, for example, an event that updates a book, and then a Lambda function that triggers that also updates the same book, then that will trigger the same function and the same function and the same function over and over again. So it's not something I ran into in real life, but I guess it's possible if you're not mindful of it.
Okay. Well, in which case, looking at the time, it's just gone 6:45 in the evening now. If we have no other questions, I'm going to suggest that we take a break of 10 minutes so that everybody can get refreshments. Unfortunately, we're online. We can't offer you the refreshments, but please, I hope that you got something you can enjoy. And we will see you back at about 5 to 7 for our second speaker. So see you soon, everybody.
Thank you.
Thank you, Luc. And welcome back, everybody.
Hello.
I hope you are all freshened up and ready for our next talk. Maybe Stace, would you like to introduce our next guest?
Yeah, our next speaker is Sean Feldman, a contributor to NService Bus, an advisor to Microsoft's Azure teams, and an Azure MVP. He likes tinkering with various Azure-related services and is in seventh heaven when a cloud and distributed technologies are combined. When he's away from his computer, he's having fun with his family and I hope I can pronounce this correctly, his Malamute. And so, Sean, welcome.
Thank you, Stacy. Thank you, Andrea.
How did I do with the pronunciation?
You're doing well.
Thank you.
I had to look that up on Google.
Yeah, the full name is
Alaskan what it is?
I'm sorry?
Could I ask what a Malamute is?
Alaskan Malamute. That's one of the 3 major Nordic breeds of dogs.
Oh, awesome. Very nice. And you're going to be speaking to us this evening about Azure Functions Elevated, and I really can't wait for this one. As I work in a Microsoft shop, this one is going to have a nice impact for me, I imagine. So, Sean, if you're ready, I will make sure that you're on the stream and take it away.
Thank you so much. Good evening, everyone, or good time of the day, wherever you are. I'm pretty sure you're not sleeping, so it's still not night. I'm Sean Feldman from Canada, Alberta, or Calgary specifically, and I'm here to talk about Azure Functions Elevated, and what that elevation stands for, we'll see in a bit. So first of all, the agenda, because everyone wants to know what's coming. We're going to talk about raw Azure Functions really quick, just to highlight the challenges, some of the challenges that any native technology has, no matter if you're using Azure, AWS, or GCP. We're going to look at Azure Functions with NService Bus. And if you have attended, I believe, February session, there was a talk about NService Bus, what it is. It's a messaging framework, middleware on top of any messaging service that, mainstream service that you would be using, that helps to focus and provide productivity. We're going to look at a couple of samples, assuming the time will permit. And in the end, moving forward, what does that mean? What are the options? What the future holds, right? Everyone wants to know that. All right, so serverless. It's a great way to build backend parts of the system, focusing on the project objectives and not the infrastructure. That's the main thing that we were sold on with serverless, regardless of what platform you're using. In Azure Functions, for example, it's a great way to develop a development model for event-driven world, similar or equivalent to what Luc was describing before a few minutes ago with AWS and Lambdas. The concept is very straightforward for all of them. Something happens, it triggers a function that needs to run, and optionally, there is an outcome of that function. And we'll focus on functions in this talk, even though it's the same concepts for AWS Lambda. And as a matter of fact, NService Bus can run with both. All right, so the big question, why NService Bus? Glad that you asked. NService Bus as a framework supports a variety of messaging patterns and workloads on multiple transports. So it could be Azure Service Bus and storage queues for Azure specifically, or Amazon SQS for AWS, or RabbitMQ, or anything else. In essence, it allows developers to focus on the core logic, fully abstracted from the underlying infrastructure. And as Luc pointed out earlier, you don't want to focus on the things that are commodity, right? You want to stay focused on the business logic. And even though his presentation was more on the side of less code, more service provided capabilities, in my talk, I'm actually going to focus on the opposite side of the spectrum, where the code is important. And still, after answering this, you probably have a question, seriously, why in Service Bus? Why not just raw functions? That's a good question to ask. The value of Service Bus, the value that it brings to the table when working with functions, is to help and elevate. And the reason why I'm saying elevate is because the truth is the world is not one size fits all. I'll focus on a few things during this session, but remember, everything we'll see applicable not just to functions, but also AWS. So the real world is messy. It's comprised of virtual machines and containers and clusters and web applications running as paths or functions. A lot of times it's a hybrid world, right? Something running on premises and something running in the cloud. And when it's running in the cloud, some of the work could be expressed as an implementation in paths, some as functions, you name it. The real world is a mix. And wherever your system is solely one of those flavors or a mix of a few, and Service Bus lands itself anywhere, allowing to focus on that business development without spending too much time on the mundane infrastructure concerns, including functions. About that, let's talk about functions. And first thing, as a quick refresher, the anatomy of Azure functions. Let's take a simple function, right? Because Service Bus is all about messaging, and messaging is the blood work of almost any serious system, especially in the cloud, where asynchronous nature is de facto the standard. We're going to talk about functions that are triggered by messages. Usually, messages coming from one of the messaging services. I'll focus on Azure Service Bus. A trigger component is responsible to receive that message and hand it over to a function, which is the custom code. That function is executed with some of the custom code. As it was pointed out earlier, ideally functions are small, focused on one thing at a time. And as a result of that, potentially provide some output in form of dispatching some messages, like, for example, publishing notification events, which are then by functions runtime translated from the output to a real message that goes out. Now, what that code would look like, obviously, this is an oversimplified function trigger, but this is more or less the function body, right? We have function name, my function, which is triggered by a message coming from my queue, and we publish into my topic, whatever the result is, and I've emitted processing logic just for the sake of simplicity. It looks simple, right? I should say simple to write, but not to grow and maintain. The reason for that is a few drawbacks, like I said, for any technology, including functions. Let's dive into those real quick. So first of all, the message that is coming in is arriving as a string. Now we need to deserialize that string. And while it's possible to turn it into a plain old CLR object, a class, it still requires some work. But you might say, Sean, what's the problem? I'm going to just put my CLR, POCO, and my class type, and that's it. I don't need to deal with deserialization. Well, yes, it's true we can do that, except it's only going to accept JSON and XML object serializer. So if you are not using JSON or you're not using the legacy serialized messages that used XML object serializer, you're out of luck, which means you need to fall back to the string and deserialize it yourself. So if your systems or third parties send messages in XML format or Bison or anything else other than JSON, you have to drop down to custom code and infrastructure related code. Next, if we want to emit a message, we have to be concerned about how to do that. And we have to keep in mind that synchronous or asynchronous method. Are we emitting a single message or multiple messages? Do we use SDK types or not? And to make it a bit more sophisticated and complicated, unfortunately, there is a whole slew of options that we need to choose from. This is just, the documentation. So we could use out, and we could use out string and out byte and out brokered message, which belongs to functions generation 1. But if we're using asynchronous method, then we cannot use any of those. We have to use iCollector and iAsync collector. And then the question is, what is the difference between iCollector and iAsync collector? If I'm using an asynchronous method, should I by default go with iAsync collector? These are all the questions that you have to understand beyond just the code in the function itself. So that simplicity is slowly fading away. Not to mention that constantly we get new options. For example, with the latest Azure Service Bus SDK, there's yet Service Bus message type that also can be returned. So as you can see, there's plenty. And we were talking about that simplicity of the code, right? And understanding whether it should be iAsync collector or async collector. And the truth is, you have to understand those types because iCollector sends messages immediately. It's an immediate dispatch, where iAsync collector batches those messages and flushes when the function is completing. So again, not very obvious, and you have to know all of those details. Something to maintain down the road. Next is what's happening about processing that is failing, because functions are great, but nothing is 100% resilient. Failures will happen. So gladly, there's an error handling and retries now built in the latest versions or few last versions of Azure Functions. And those retries are either fixed or exponential, right? With one of the two attributes on top, fixed delay retry, exponential backup retry. But when you're doing messaging with Azure Functions, there's a chance of misalignment between number of retries defined on the function versus number of delivery attempts that are defined by Service Bus incoming queue, which might result in the incoming message going to the dead letter queue. Also, another challenge is that there's no way to define something that would be sort of unrecoverable exception. And what that means is a retry that should not take place when that type of exception is happening. So for example, if a third party is down, if I'm going to retry the message 10, 20 times with backups, it's not necessarily going to help me because I know from the history of that service that if it's down for a long time. So better discard that message or mark it somehow. Unfortunately, not possible with functions. The other challenge is all the messages failing retries or functions that are failing all the retries, exhausting those, are eventually dead lettered to a queue called dead letter queue. And that queue exists per each input queue. So if we have my queue input queue, it will have its own dead letter queue. And if we need to monitor that queue and all other potential queues, which means resulting in multiple dead letter queues that essentially needs to be monitored by operations team. And that can become plenty. Now, why plenty? Is because the approach with Azure Functions or serverless in general is to minimize the scope of what a single function is responsible for. And that's a good practice. Unfortunately, that good practice has complications. So for example, in this example, I have 3 different functions, each triggered by a different queue because probably they're dealing with different message types. So for example, order received, order paid, order canceled, right? We want to split the responsibility. Because of each message type, there's usually a different function defined to keep that logic separately. It also means that down the road, we might start bleeding because we have to define all of these functions separately. We have to define retries on them separately. We have to monitor failed queues separately. As you can imagine, doing it for 3 queues is not a challenge. Doing it for more than that is essentially bringing to something that is not really maintainable or desirable. So now we're looking at all of this and saying, hey, I did not sign up for this, Sean. What's the story? And you're right, you did not sign up for that. You shouldn't be signing up for that. Because functions were supposed to make it simpler to focus on what matters, right? So let's focus on what matters, the core logic and how we get there. What I will do is compare and contrast the anatomy of Azure Functions or raw Azure Functions with Azure Functions and Service Bus. And it's important to keep in mind that in-service bus is not replacing functions, it's augmenting functions. So it's with AWS Lambda. So what in-service bus is doing, it's leveraging the trigger part of Azure function and sort of replacing the processing and the output aspects with its own custom code, which is well tested in the last 10-something years and tried out by multiple customers. When in-service bus is processing messages, it takes care of the output. It does not trigger it does not leverage output bindings, and all the features are encapsulated and augmented on top of native functions and the messaging services. All right, let's skip straight to some code. First of all, this is an equivalent of a function or function replacement with in-service bus. Let's analyze quickly what it stands for. So my request class is a message type. We don't deal with strings, we don't deal with byte arrays, we deal with meaningful contracts. So my request class is C# plus that has all the properties, right? Describes exactly meaningfully what it stands for in our domain. Then we have a little bit of in-service bus infrastructure, a type called iHandleMessages. So our handler is my request handler is implementing logic for my request class, and by invoking this syntax, we get automatically a method signature, which is called handle. Whenever a message of type my request class is coming in, in-service bus is going to trigger this method, passing in that message as a .NET object and a context object. And the context object is just passed in by in-service bus, similar to a context provided, for example, by Durable Functions API, which is basically very much similar. It allows certain operations, right, within this context of execution. Usually it's related to messaging, such as publish an event or send a command. And the reason why I'm distinguishing between the two is because in-service bus also assigns meaningful context to message types. There's an event, which is a broadcasting, basically declaration of something that happened in the past, and multiple receivers can get that event. And there is a command, which is a unicast sent message. It has a specific destination, it has an intent, and some sort of expectation of what will happen as a result of that message. So in-service bus does that, distinguishes between those two. All right, so what do we do in terms of the processing? Doesn't matter. We could be writing to the database, Cosmos, SQL, storage table, do whatever we want, and we could potentially emit messages or send messages out. In this case, what I'm doing here is I'm publishing a new event called something happened. Again, strongly typed events, strongly typed messages is what we want. All right. Does context as I said, context is capable of not just publishing, but also sending. In this case, for example, I want to send an email. Again, it's a command. So I'm sending a message because I have an expectation of what will happen as a result of that message. Now, in terms of order, the order doesn't matter. What happens is that in-service bus is always buffering by default, right? So when we say publish, it's not actually going out as a message because we want to ensure that the processing of the function is successful. Once the function processing, the custom logic is executed, function is completing, only then the publishes or sends are going out because the function has completed. Now, in terms of recoverability, similar to Azure functions, both immediate retries and delayed retries, or exponential backup retries, are supported, but there is more. There is an implementation of a concept called unrecoverable exceptions to allow you to skip the retries altogether for certain exception types or for certain errors. And also there's an ability to entirely replace the recoverability policy. So for example, if given certain conditions, rather than implementing 5 retries, immediate retries, we want to do only 3 or skip the exponential retries, all of that is possible. What happens when a message fails processing after all retries? Well, something that is better than that letter Q. It's actually moved, the failed incoming message is moved into a centralized error queue. There are multiple benefits of having this kind of mechanism rather than just dead letter in messages. One, it's centralized, it's easier to monitor. The second thing is you don't need to distinguish between messages that failed as a result of logical problem or infrastructure problem versus poisonous messages. So, and service bus only dead letters messages when those are not processable at all. For example, damaged message. But if it's a logical error or an exception thrown by a third party or something else, the message is retriable in theory and is always moved into centralized error queue if failed retries. What happens if I have multiple messages? Well, similar to Azure Functions, you have a handler per message type, right? This is how you can separate the work units. It's very clean, very simple, and there is no infrastructure concerns here. You don't have to specify the retries. On top of each handler, you don't have to do the serialization and all of that. It's just focus on whatever the processing, the custom logic, and the events and the commands that you want to publish. All right, you're probably at this point where you're saying, okay, this is a nice trick, but Sean, how do I take those handlers and actually put in my function and get going? Perfect, let's have a look at that. Every function has a function start. Well, unless you write in something static and it's not, I wouldn't say it's not production grade, but it's not something that is of a significant complexity. Usually there's a startup class where you configure your dependencies, services, whatnot, for example, Entity Framework Core, and Service Bus is registered in exactly similar way. Functions host builder used as an extension point where we call use and Service Bus, providing and Service Bus endpoint configuration. Endpoint configuration or Service Bus triggered endpoint configuration is the gateway into configuring and Service Bus endpoint. Endpoint is a logical construct that represent all those functions, right, that are running. That includes, the configuration includes recoverability, serialization, message routing, which I haven't talked about, and we'll chat about this because actually I'll cover it now. When you want to send a message or publishing an event is not difficult, but sending messages, you have to know specifically where, to what queue, or in terms of Service Bus, what logical endpoint that message should be going to. Instead of continuously using those magical strings or remembering destinations, Service Bus provides a routing mechanism, which you configure once, and all handlers are aware of it and know what message type should go to what destination. Pipelines configuration, again, Service Bus has very robust incoming and outgoing and processing pipelines, which can be mutated, modified, even replaced if you know exactly what you're doing. So basically advanced extensibility. So that's what endpoint configuration is responsible for. Now, the next one is, let's have the second part. That was just the registration of Service Bus. There needs to be that augmentation or connection between Service Bus world and Azure Functions. And it's done by a simple Service Bus triggered function. It's a class that you can define as any other function with injected iFunction endpoint provided by Service Bus. This is the way to get into Service Bus world, to kick off the Service Bus processing, right? We define a dummy function that is triggered by the input queue. And at that point in time, we invoke the iFunction endpoint processing method, passing in the message, the logger, and the function's execution context that are injected by functions runtime. At this point in time, function is delegating all the processing and everything to Service Bus. And at that point in time, the magic happens, and Service Bus knows how to wire all the handlers, execute all of them the way they need to be, send out messages that they need to be, and basically completing the function cycle. Now, if we look a little bit into the future, kind of sneak preview, sneak peek preview. The way it looks today is we have to have the startup function startup configuration, and we have to have that dummy function, service bus triggered function, in order for everything to work. Thanks to C#9 code generators, it will be possible to eliminate the second part altogether, leaving just the startup function and registering and service bus. And probably something like in service bus endpoint, where we would provide the name or the queue name, right? Warning, this is not there yet. It's something that will be coming probably shortly, but this will tremendously simplify the wiring, because all you will need to do is just add this configuration to use in service bus. And this is what it's going to look like, right? Extremely simple, plus the handlers, obviously. So since we're talking about handlers, let's actually dive into the code itself. And I've prepared two examples. One is very simple, but kind of real world example. It's a full duplex example where a service bus is going to be used to support a concept called conversation, where a message can be associated with originating message without necessarily needing to keep the information of the source where it's coming from. It's a ping pong. So one endpoint will be sending a command, a message called ping. The other endpoint will receive it and respond back, reply back with the reply pong, or the message type pong. To make it a little bit more interesting, we'll first create two endpoints as console applications, right? And then what we'll do is we'll take one of the console applications and turn into Azure function. And we'll see a real world example of how you can integrate between functions and on-premises world if you have, let's say, a system that is running on-premises. That will be the first sample. The second sample is going to be a bit more advanced, user registration flow. And in this example, we'll look at a feature and service bus feature called Saga, also known as coordinator pattern. It's an equivalent of Azure functions concept called durable functions, except Saga is a much more refined, as well as much simpler to code and understand and maintain. What this sample will do is it will mimic a registration workflow dumbed down to very simple console execution, where we will have an email and a password, for example, submitted by a user. It will be registered as an intent. We will not write anything to the database because we don't know if the user is confirmed or not. Also, we don't want to create additional logic that then goes and wipes all those intents for the registration that were not completed, right? And the way we'll do it is we'll send confirmation link to an email and wait for 24 hours for the registration to be confirmed. After 24 hours, if we haven't received anything, nothing has been completed. And again, we're not going to check ourselves. We're going to rely on the eventing or event modeling kind of thing. We'll send another reminder to confirm the link. And if after 48 hours we haven't received any confirmation, that means the person was not really interested in registration, or they changed their mind, and we'll just terminate the intent. No damage done, nothing's written to the database, nothing to clean up. So these are the two samples. Let's switch to those. As I said, the first sample is a ping pong sample. I'll try to increase the font if it's too small, but just a quick overview. Two console applications, as I said. The first one is the ping endpoint. Again, nothing spectacular. We are creating endpoint configuration called ping. That's the logical endpoint. You also can think of it as a service. So we have a ping service and a pong service. We do specify serialization. In this case, I want to use Newtonsoft serializer to serialize the messages. And I'm going to use Azure Service Bus as the transport, supplying the connection string. And this is, for example, the routing specification. I'm basically saying whenever there is a message of type ping that is sent up, please send that to the destination, to the endpoint, logical endpoint called pong. Okay, so from now on, I do not need to be troubled to remember where ping commands should go. The underlying infrastructure will know automatically to route message to the correct destination. We can always override it, but that's not the intent. We start the endpoint, And we can infinitely loop through creating our messages. This is how simple it is to create a message. I'm just constructing a ping. Ping is a class, has a property issued on. And what I'm doing is I'm basically saying endpoint, send the message. As simple as that. Now, on the other side, there is a ping handler on the Pong endpoint. And if you remember the syntax that we've seen, I have a handler class that implements I handle messages of type ping. When the Pong service or the Pong endpoint will receive a ping message, it will trigger this method automatically, passing me the object, the CLR, the Poco.NET object, which has properties. I don't need to deserialize it. I don't need to do anything to work on it with it, sorry. And what I'm going to do is I'm going to log a message just to see on the screen that this has happened. And I will be replying back with the Pong message, right? Another class, custom class to describe business contract. And notice for the reply, I don't even need to specify that the reply should go to ping in this case or any other destination. And Service Bus is wiring the conversation ID automatically. It knows who was the originator of the ping message, and it will route the Pong to the right place. All right, and on the ping side of things, I'm also going to put a handler, right, which will receive the Pong and complete that cycle by just writing an informational message into the logger on the screen. All right, let's run it. We'll run it quickly. Just a sec. As console applications, so we will have two console windows. One for ping, one for Pong, right? Both endpoints are starting. So ping is ready to send messages. I'm going to send the message. Ping message has sent. We receive the Pong.
Sean, we're not seeing your console windows right now. We're just seeing a very beautiful vista of a lake.
Oh my God. I apologize. I've been talking for a few minutes, and I guess I need to share a different screen. Here we go. How about this?
Can you maybe make the fonts a little bit bigger?
Yes. How
Awesome.
about that? Right. So let me repeat quickly what I was saying in the last 3 minutes, and I apologize for that. So again, I will minimize this one and make it a little bit bigger. So these are the two endpoints, the ping and Pong. The first endpoint, ping, the configuration is really quick. The logical endpoint, selecting what serialization I'd like to use, what transport is going to be used on the endpoint, routing information to make sure that whenever a command or a message of type ping is sent out, it's always directed or routed to the Pong endpoint. Enable installers, I'm just cheating here a little bit because I'm lazy to create infrastructure, so I'm asking in Service Bus to create all the messaging infrastructure for me. Starting the endpoint and dispatching the messages by creating objects of the ping class, assigning the datetime, and asking in Service Bus the endpoint to actually send the message without specifying the destination, because it should already know we taught it about the routing, right? And on the Pong class, on the Pong endpoint side, I've defined a handler. That handler is handling the ping messages. So whenever a ping message is received by the Pong endpoint, this handler is going to be executed with the ping message as an object of ping class. I don't have to deserialize it. I don't have to do anything. We're going to log the fact that this happened and reply back with a Pong message. And when we reply, we don't have to specify the destination or the address, because in Service Bus keeps the conversation ID and it knows where the original message was coming from. On the ping side, or on the ping endpoint, I'm going to have a Pong handler, which is going to do something very similar. It's going to log the fact that we have received the Pong, the response, and complete that cycle. I'll run it as 2 console applications on purpose, because I want to show you what it would look like first, and then we convert it into a function. It's going to be hard, but we can make it. So at the bottom of my screen, and hopefully I can make it a little bit bigger. This is the PONG endpoint, and this is the ping endpoint. And once we submit the message, ping message was sent, we receive the PONG response. If we check the PONG endpoint output, we can see that the original ping definitely was received, and that was the trigger for the PONG. Fantastic. So we can see it running in a console application. This is great, Sean. How about we turn PONG endpoint into a function? All right, let's do that. It's going to be difficult, but we'll figure it out. So let's have a look at the PONG function implementation. Startup class. Remember, we've seen this earlier. What I'm doing is I'm defining first of all, instructing functions to use end service bus and configuring the endpoint, except in functions, there are certain defaults that are already pre-configured, like the Newtons of JSON serializer and certain recoverability. So I don't need to do it manually unless I want to override those. And I'm specifying the function endpoint, which happen to be the endpoint name, the PONG. So that's the first part. The second part is that dummy trigger that we have to connect between end service bus and functions, right? And all I'm doing is when the function is service bus based triggered function is triggered, I'm passing to the iFunction endpoint request to process the message. That's all the wiring. And hopefully this is going to go away soon. We won't need to do it either. Now, how do I write my code in the function if I no longer use the function SDK itself? Well, that's what I do. I just literally copy the same code we use for console application, because it doesn't matter if I run on premises, if I run in functions, if I run in a container, web jobs, AWS, Lambda, and service bus abstraction is the same abstraction. I have a handle method in my handler class that declares that it handles the ping message type. I get my object of that concrete class, and everything stays the same. So let's run that. Just to see that, I'm not tricking you to think that it's that simple. Again, we're going to have the ping console application, and we're going to have the PONG function. And you can see that this is definitely function, right? We're running the PONG function triggered by service bus. All right, let's send a ping message. Ping message was sent. We got a response. Who handled the response? Definitely our function. So notice that our function is now not coupled to the functions SDK. And whatever there's going to be a new SDK from functions, or there's going to be, for example, out of process or isolated worker, my code will stay the same. So I can move this code from on-premises into functions, from functions from one SDK to another SDK. I can unit test it. I can do whatever I want. I am not coupled to the functions SDK, and I am not prone to the challenges associated with the native functions. So that was the first example. Let's switch quickly to the second example, just as a refresher. What we're going to do is implement this registration workflow. And with the registration workflow, you will see that it's a bit more sophisticated because we have something that is more stateful over time. So more aligned with durable functions, if you wish. For the purpose of that exercise, different solution, and I will not go through HTTP requests and web applications. I'll just mimic that with Postman. But let's briefly go over what it is. I'm not going to focus on startup and trigger functions because again, they are exactly the same. Perhaps the only thing that might be of an interest here in terms of the endpoint configuration is that I'm actually creating the topology myself rather than delegating to anyone else. But from end service bus perspective, it's still endpoint configuration. I'm using persistence in this case. Azure Table Persistence. It's a storage service. And the reason I'm doing that is because if you have something that is stateful, you have to retain that state somewhere, right? Especially if your execution is spanning a period of time. In asynchronous world, you have to persist that state. And yeah, I'm using Azure Tables for the persistence. And what we will be looking at is a Saga feature. Now, this is a bit overwhelming, but you can find documentation on the official website, and ping me anytime. I'll be happy to elaborate and explain. But let's have a look. What is it? So I have a registration workflow. It's a Saga, and the Saga has a state, registration state. That state is basically retaining email, password, confirmation code that we will assign to the user to be used in the confirmation link. Now, again, this is not production grade code, so please don't code it one-to-one. Don't try that at work. You can try that at home. We are stating that our Saga is started by a message called start registration. Okay, again, it's a .NET class. Here's the implementation. That command will have an email and a password. It's less important because when our messages are expressed as contacts, meaningful types, it's easier to understand it without necessarily looking at the details. And we're going to handle messages such as process confirmation, which is going to arrive when a user clicks the link or confirms their registration. And we're going to handle an event, registration completed. Notice the name convention. It indicates that something already happened, right? It's just a notification. It's an event. We'll handle that, as well as we'll handle 2 timeouts. Again, it's a Saga concept and service bus concept, where we can trigger our own workflow, our own Saga, after a certain timeout. So the first will be after a period of 24 hours, another one 48 hours. Now, for the sake of this demo, I'm not going to wait for 24 or 48 hours. We're just going to pretend like we do, and we're going to do about 30 seconds for each to demo things. Now, one thing that is important to keep in mind is that a workflow is just an instance of a workflow. There could be multiple users. How in Service Bus is connecting the messages associated with one user and is not mixing it with an instance of a Saga or workflow for another user. And that's done by configuring the mapping between the Saga instance and the messages coming in. And what I'm doing here is I'm saying, hey, the Saga instance is identified by an email because that's the unique piece of information. And all messages that are coming in have an email property. That's how I want the connection to be established, right? So the first message that will be kicking off, and I'll collapse the mapping, it's less important. The message that is starting a Saga is always start registration. Once that message arrives, what we will do is we'll generate confirmation code and URL so that we could communicate that. You know, we could, for example, send an email, whatever, but I'll just copy the code and that's it. And then we're going to request a timeout for 24 hours. Now, what happens with the request after 24 hours? Here it is. Here's the timeout. When that happens, this method is invoked, similar to message handlers, right? And we could, for example, send yet another reminder about activating the account. And then requesting another timeout for 48 hours, right? Basically, the Saga goes dormant, goes to sleep. After 48 hours, after its second timeout is kicking in, again, similar to a message handler, this timeout method is going to be invoked, right? And at that point in time, we kind of said our rules are, if we haven't received confirmation until this point in time, we will be completing, marking the Saga as completed. Now, what happens if we do receive a confirmation? If we do, then the process confirmation message will arrive, and I'll show how those messages are created. We'll confirm that, just sanity check, the confirmation code that has been received is actually matching what we've created for this user for this specific workflow. If they don't, well, we have a problem. Probably should log, investigate, but I will not complete the registration. Only those two are matching, we will publish an event, probably register in database or something, and then announce to the world that, hey, registration has been completed. This could be going to customer relations or customer sorry, I'm lacking the departments, customer success, for example, or customer relations, sending an invite package or welcoming email, whatever it is. We basically announcing that registration has been completed. Not only that, ourselves, we're going to subscribe to this as a separate event because we're striving to do one thing at a time, not multiple operations, and we will complete the saga, right? We will complete this workflow. Customer has registered successfully. Now, because I don't have a web application and yet still I want to start the registration and being able to confirm confirmation, I have created 2 dummy HTTP triggered functions. One is called HTTP register, basically a function that exposes an API endpoint where we receive HTTP request with a username password. We're going to turn that into a message, right? Again, start registration, not just a message, meaningful business content. And we're going to use nService bus with iFunction endpoint that is injected to dispatch that command. Again, I don't need to say where it's going because my message, I did not provide for this message type any routing configuration. But what I did is I locally prescribed to send the message to myself, to the endpoint that is currently executing, right? Again, customizations over routing or advanced features that nService bus provide. So I'm going to be sending a message to myself, to my endpoint, to my function. And that's how the saga will be kicked off. Now, when confirmation is arriving, again, similar pattern. What we're going to do is we're going to expose a confirm API endpoint, which will receive the email address confirmation code from the user. Again, construct process confirmation message, right? Again, meaningful contract, and dispatch that using nService bus as a reliable message to ourselves, so that we don't have to provide the routing configuration. With that, let's run it and see what's going to happen. So again, we're going to have, in this case, just single output window due to the fact that all of our functions are running here. So we have the confirm API endpoint, we have register API endpoint, and we have the trigger, right? That is kicking off the workflow. That's the connection between nService bus and Azure Functions. And there is also a timer function that's a little trick to wire up infrastructure. You don't have to use that. I just did it for the purpose of the demo. All right. So first of all, I'm going to use Postman. Let me quickly show you what it looks like. I don't know if it's probably not working well. So what I'm doing here, not entirely sure how to make it larger, but we send into the /API/register email and password as an object, right? Once we send that, it's been received, registration, response, and we see that there's a confirmation email sent out. I'll pretend that I'm opening that email and clicking the link. Instead, what I'm going to do is I'm just going to invoke the HTTP endpoint, and I'm going to send that code. And you can see that registration for this user has successfully completed. Fantastic. Now, we scheduled timeouts. What's going to happen with those timeouts? Well, they are going to be discarded, right? And the reason why they will be discarded is because that saga has completed. That specific workflow instance is no longer relevant. So those messages can be safely discarded. What happens if I'm going to try and register, but not necessarily do anything about that registration code, right? Just a second. This is unnecessary. I might need to stop just because I've used this ID already. Let's have a different ID like this. No saga found. Okay, here we go. Those are timeouts. Confirmation for Feldman Sean 2 has been received. Oh, I'm sending confirmations. My bad. Definitely wrong place to submit messages. Okay, so this is the registration intent. 2 has already been used. Let's go with 10. Like Windows, we'll skip all the versions all the way to 10. And we have received the request to register, right? That's the intent. The confirmation email was sent out with the code, but you know what? Customer remorse. I've decided, nah, I don't really want to register for this. It was really interesting at the moment when I saw whatever I saw. Now I don't have time for it. I'm just going to ignore it. What will happen? Again, not 24 hours, but 30 seconds. After 30 seconds, we should see that the workflow is executed and a reminder is sent to our email, to this user. Again, I'm going to ignore it. Too busy, don't have time for this. And what should happen is the workflow should execute the second timeout, which would basically lead to the completion of the workflow without registration because user has never confirmed. A few more seconds and we will see Saga completing. Just give it a few more seconds and here we go. Aborting registration for Feldman Sean 10. That's it. No database writes, no unnecessary work, no cleanups, thanks to the Saga structure. So this was the second sample. And to wrap it up, I'll just go very quick about this. Azure Function support within Service Bus was released about a month ago in May as a package for in-process SDK version 1.0. Next, what will happen is likely release support for isolated worker SDK, which is currently sort of launched as a GA by Microsoft, but still kind of gearing towards .NET 6 as a serious release. So both will be supported fully. And with that, I'd like to thank you and the organizers. It's been a heavy demo, I realize that. I appreciate your patience. And reach out with any questions. I'll be happy to answer those now or later.
Oh, that was interesting. Thank you, Sean.
That was a really cool, excuse me, a really cool session. It's I think there's a lot to unpack there. I think I'm going to be watching this one back a couple of times to kind of like get into it a lot deeper. Do you have a blog post, a tutorial, or source code that people can look at for this?
Yes, there's absolutely that. If I can share the link later, and I believe there is a docs-particular.net. I'll just open it in the window here. This is the documentation page with the documentation topics. Everything is found here. Under hosting, like I said, Service Bus can be hosted with various services. One of them is, for example, Azure Functions with the Service Bus. So if anyone is interested, that's the place to go. Or you can just search for Azure Functions and you will find everything. The documentation also includes a sample, a downloadable sample that can be pulled down with instructions and F5, run it, and see how it works.
Awesome.
Yeah, maybe you could share this link in the Discord channel if you are there.
Yeah, absolutely. That's actually a fantastic, fantastic suggestion. Let me just do it right away as we speak. And the link is there. That's the starting point.
Ooh,
Thank you
very much. And I think there's one question that I really have. It's kind of like burning inside of me. You have the two timeout functions there, but you're not hooking into the timer functions of Azure Functions. is that something internal to end service bus, which will then just trigger timer functions based on an amount of time, or is there other wonderful trickery going on under the covers to get that working?
Right. So the way Azure functions are working, it's basically a Lego world, right? So the triggers and the output bindings are not necessarily related to each other. So it's very difficult to coordinate between those two, because the design of functions is intended to be loosely coupled, which sometimes is good and sometimes it's bad. With the workflow, for example, you want to associate those timeouts with specific incoming messages, as we saw, right? Triggering the beginning of a saga and then confirmation and completion. So what's happening, because end service bus is capable of running on AWS functions, premises, Kubernetes, whatever you want, with different transports, the timeouts are expressed using native messaging, similar to what actually timer trigger is doing in Azure Functions, because they leverage one of the underlying services, storage queues, if I'm not mistaken, to in-queue the message and then pop it later. So we do something similar with end service bus, except we don't have to handle it. End service bus does it automatically. When you are requesting a timeout, behind the scenes, it's actually scheduling a message, which is triggered, and that message is wired to have all the information or metadata to associate the timeout with a specific instance of a workflow or saga.
Awesome.
So that's how it works.
That really is so cool.
It's a very nice feature. I know it's a bit difficult to comprehend in the beginning because it's slightly different paradigm, and it's not as it's slightly different from Azure durable functions. If anyone has done workflows with durable functions, but if you have touched durable functions, you can see the differences, conceptual differences, such as, for example, you don't have to specify function name or function, what are they called? Simple functions, right? If you want to, for example, process a timeout, or if you want to handle a different message or next step in the workflow, with durable functions, you actually have to instruct and you have to know what's next. Where here, we're literally driven within the workflow by the contracts and by logical assumption that it's just wired on our behalf. All I need to do is send a command, publish an event, or request a timeout.
Awesome. Andrea, do you have any other questions?
Actually, no, I just checked the channel as well, and I think this is one of those more advanced topics that people have to really take more time to learn it and to come with interesting questions. But it's nice that we have you in the channel, so we can contact you if we have any further questions. Thank you, Sean.
Absolutely. Anytime. And I realize it's late, so when people wake up tomorrow with some, wait a second, type of question, I'll be happy to answer those.
Awesome.
That's
well,
great.
Thank you very much for joining us today.
Thank you, folks. Have a good one.
Bye-bye.
Thank you. You too.
So, Andrea, that's it. That's our last meetup before the summer vacations. As we said at the start, we've now got a 2-month rest period for us to recover, and yeah, let's kind of keep our fingers crossed that this weather continues for just a little bit longer. So we will be back in, I expect, September with 2 more awesome talks. And yeah, I wish you all a very enjoyable summer.
Yeah, wish you all the best, and let's catch up some good weather, sis.
Absolutely. Bye-bye, everybody.